वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे we will study the rest part of the structure of atom of class 11th. So earlier we discussed so many topics. This is the class 11th structure of atom. Earlier we studied about so many topics, like we studied the Bose rule, then quantum number. Then we studied about the atomic number, atomic masses, mass number, like this. So today we will go through this concept. This is known as discovery of electron, that's cathode ray experiment, and the discovery of proton, that's the anode ray experiment, and discovery of neutron. Then after, so today what the topic we will cover, we will try to cover this topic: discovery of electron, then discovery of proton, and the discovery of neutron, then a Rutherford atomic model. Then after, there is one more, Thomson's model of atom. We will study here the Thomson's model of atom. And if we will have a time, because I will try to make a video of 1 hour only, so it will convenient for you to study. So if we'll get the time, then we will study the Bohr's atomic model. So have a look here. Let's start with the discovery of electron. Discovery of electron, it was done by J.J. Thomson. So he basically he used a tube, also called Crookes tube. The name of the tube is Crookes tube. Basically we say a discharge tube. This is a discharge tube we have, and this is the vacuum. One electrode is an anode, one is a cathode. As this is not fixed, this is cathode or not. We will find out if this is cathode. Then this is the high voltage current they have attached over here, and this is the switches. So what happens when some gases are here? So there is nothing happens. We put gases at atmospheric pressure. And the voltage is very high. Now that's a 10,000 volt. What the high voltage? The high voltage is 10,000 volt. So 10,000 volt is over here. So what do you observe? Then nothing happens. So what do you do? So we just reduce the pressure. So pressure is reduced. To about 10 power minus 2 atm. As the pressure is reduced, what happens? So when the pressure is reduced, the current start flowing between the electrodes, and a colored glow is observed. here a colored glow. There's a green color basically. Greenish color is observed as the as this as the pressure is reduced to 10 power minus 2 atm. So current is start flowing from cathode to anode. So as it moves from here, it strikes on the wall of the discharge tube, and the green fluorescent is observed. So this is the cathode ray. These are invisible ray we observe here. So when the pressure is further reduced to 10 power minus 4 atm, so glow between the electrodes disappear. The green fluorescent disappear. At what pressure? As it is reduced to 10 power minus 4 atm, but the current continues to flow. From cathode to anode. Now we will study about the properties of cathode. So we have to study properties of cathode. Properties of cathode. So what are the properties of cathode or the cathode rays? Cathode rays. Okay. So the first is what? First property of cathode ray, that it travel in a continuous manner or a straight line. So cathode ray travel in a straight line. So how just prove that cathode ray travel in a straight line? So have a look here. So this is the discharge tube you have taken, and this is the one is the cathode, and this is anode, and all the conditions are as per. So 10,000 volt, and the pressure is reduced to 10 power minus 2 atm. Then from cathode, the electrons move toward this one, is strikes on the wall of the discharge tube, and what happens during this? So what do you do? How you just prove that it travels in a straight line? So this is cathode ray. So in the way of the cathode ray, we put an obstacle. So this is an obstacle. So what you observe, that it makes shadow. So when the shadow is formed, when the light comes from the front, when the light comes from the front, then it always makes shadow. So this experiment proves that when you put some obstacle in the path of cathode ray, then shadow is formed. It proves that cathode ray travel in a straight line. Now, second property we have to study. Second property is cathode ray have a particle nature. Cathode ray have a particle nature. So what the meaning of the cathode ray have the particle nature? So again, we just take the discharge tube just like this. Now cathode is moving towards anode. Okay, now so what do you take? We just take a metal wheel. So this is a metal wheel. So when cathode ray strikes on the metal wheel, then this metal will get a start. It shows rotation. So when there will be a rotation, when something is strikes on that, it means it will apply force over that. And when there is a force, there is mass in acceleration, and when there is a mass, there is a particle nature. So it proves that cathode ray have a particle nature. Now we have to discuss about the next property. Next is as the cathode ray strikes on a metal foil. Suppose we put a metal foil over there. So as you put the metal foil over there, then metal foil will get heated. So cathode ray shows heating effect. What do you say? Cathode ray shows heating effect. How? So as I told you, as you put, so this is the cathode ray. So as ray is passing through from cathode to anode, so as you put a metal foil, so metal foil get heat, it become hot. So when a metal foil become hot, it means due to a strike of the cathode ray over the metal foil, it got heated. So this shows, we can say cathode rays shows heating effect. Now the next one. It also when you put some photographic plate in the way of cathode ray, so photographic plate get damaged. So you can say it damages the photographic plate. Damages, or a proper word we can use, affect the photographic plate. Affect the photographic plate. Now the fifth one, it also show ionization effect. What the meaning of the ionization effect? So as some gases passes through, when you put some gases in the way of the cathode ray, they get ionized. It means it have a ionization effect. Similarly, it also shows green fluorescence. Shows or produces, the proper word we can use, produces wait a second, it's not removing. I want to remove this. Yeah. No. So it produces green fluorescence. Green fluorescence. As I told you earlier. So as cathode ray moves, it strikes on the discharged wall of the discharge tube. When the pressure is reduced to 10⁻², it shows green fluorescence. So this is about the green fluorescence. Now ionization effect, heating effect, and it also damages the photographic plate. It also shows penetrating effect. So whatever the penetrating effect it shows, so as we put some thin foil in the path of cathode ray, it penetrates it, so we can say that it have a penetrating effect. Now the next one, as we know, the cathode ray is made of metal particle, so it is a particle nature. And as we there is a last property we can say, since it moves from towards the anode is basically the positive charge, so it is proved that cathode ray is negatively charged particle. Now ninth, we can say then finally it was found that cathode ray is nothing, it is electron only. So cathode ray is nothing, it is electron only. So electron only. So J.J. Thomson in it have proved this thing. Now the charge by mass ratio as for this one, it comes 1.76 into 10 power 8 coulomb per gram. You should keep in mind the charge by mass ratio for the electron. So for the now if you want to find out the mass of the electron, so mass of the electron will be what? It is the charge of the electron upon charge by mass ratio of the electron. So charge of the electron is what? Wait a second. Charge of the electron, as you know, charge of the electron is equal to 1.6 into 10 power minus 19 coulomb, and E by mass, charge by mass ratio, in the case of electron it is observed 1.76 into 10 power 8 coulomb per gram. So we can find out the mass is equal to charge upon charge by mass ratio. So it is 1.6 into 10 power minus 19 divided by 1.76 into 10 power 8. So it will come near about what it will come. So it will come 9.11 into 10 power minus 28 gram. So this will come 9.11 into 10 power minus 28 gram. So this is about the cathode ray experiment. Now we have to move towards the anode ray experiment. So this is your anode ray experiment. Now anode ray experiment. So with the help of anode ray experiment, we can find out that we can discover the electron, proton. With the help of cathode ray experiment, we discovered electron. Now with the help of anode ray experiment, we will discover the proton. Now in this time we will take anode ray in this such type of, this is the cathode ray. This is a perforated cathode having the holes. We took the perforated cathodes having some holes. And then after we here the anode, and at the same condition when the voltage is 10,000 volt and temperature is reduced, then what we observe, then rays are coming from anode and is moving towards the cathode. Cathode is already negatively charged, it means it must be positively charged particle. Characters or the properties of the anode ray are the same as it was for the cathode ray, more or less the same. How? Have a look here. So properties of anode ray. Properties of anode rays. So what are the properties? Same properties. It is travel in a straight line. So travel in a straight line. So as we in the similar manner as we got the idea, so as you put the some obstacle in front of cathode ray, similarly we will put some obstacle in front of anode ray, and so it will show the shadow as you put over here. Suppose we put obstacle over here, then it will show the some shadow. So it will prove that anode ray travel in a straight manner. Similarly, if you want to the second one what you have? Second one you have like it have a particle nature. So particle nature shows. So as you put some fine metal waves in the path of the anode ray, it will get rotation. When the rotation take place, when we apply the force, and when a force is applied, there is the mass. With the mass, there is a particle nature. In the similar way, it shows the it damages photographic plate, and it shows heating effect, so it have the heating effect, so just like this, so now all the characters are the same, but where the difference some different thing is over here. Then since it moves towards the cathode, which is negatively charged, so it must be positively charged. So anode ray is a positively charged. What you write over here? Anode ray is positively charged particle. Positively charged particle. And finally it was found is nothing. It is a proton. And but one more thing is that there is a difference between cathode ray and the anode ray. The charge by mass ratio is different for the particle constituting anode rays, when different gases are taken inside. So E by mass ratio is a different for different gases, whereas E by charge by mass ratio is the same for different gases in cathode ray, and here charge by mass ratio is different for the different gases. Okay, so this is the thing you should keep in mind. Now one more thing is what the charge by mass. If you want to find out the mass of the proton, so again, as you know, the charge of the electron is 1.6 into 10 power minus 19 coulomb, and E by mass ratio is fixed. So E by mass ratio in this case is 9.58. It will vary for the different gases, but it have been found 9.58 into 10 power 4, not 9.58 into 10 power 4. So mass you can find out. E by mass is they have given 9.58 into 10 power 4 coulomb per gram. So mass can be obtained how? So put E by M, charge upon charge by mass ratio. Charge is 1.6 into 10 power minus 19 divided by 9.58 into 10 power 4. When you solve, it will come approximately 1.67 into 10 power minus 24 gram. So this is the mass of the proton. So anode ray is nothing. Anode ray is a proton only. So this is the concept regarding proton. So how the proton is discovered. So proton can be defined like that which carries one positive charge and over the hydrogen atom. Sometimes we also say proton H plus as a proton. How the H plus is proton? Have a look here. Hydrogen is the only atom or the element having one electron, one proton, and no neutron. If you consider it as a hydrogen, so hydrogen have one electron, one proton, and no neutron. One electron, one proton, no neutron. But when you put plus charge over here, then what will happen? So it will be no electron, only one proton, and no neutron. So H plus is nothing, it is proton. Usually we use this term H plus. So H plus is nothing, it is proton only. So you should keep in mind this concept. Now, so this is the discovery of proton. Now we'll just discuss about the discovery of neutron. Discovery of neutron. So how basically it was discovered by James Chadwick. James Chadwick. So when the James Chadwick bombarded, there is alpha ray. Alpha ray is what? Alpha ray is nothing but the helium ion. The helium is 2,4. No? So when James Chadwick bombarded alpha ray or the helium on beryllium. Beryllium have atomic number 4, mass 9. So it gives carbon 12, 6, 12. Now have a look at 9 to. Sorry, I put it wrongly over here. It's 2, 4. Just keep in mind. Helium 2, 4. 2, 4 over here. Now 9, 4, 13, but it's 12. No? And 2, 4, 6 is okay, but 9, 4, 13 is 12. So he thought there is one mass is less over here. So he have given the term neutron. He have told that there is something which have one mass but no charge. No? So he found that there is something which have charge. Charge is 0 but mass of 1 unit. Nah? And so he finally got it. This X is nothing. X is neutron only. So neutron have no charge, only one mass. He have given one more, like same alpha helium 2, 4 bombarded over boron like this 5 and 11. So he got a new atom, that is nitrogen 714. Now 11, 4, 15. 5 to 7 is okay. 4, 11, 15. So there is one mass less. Then finally he got the no charge but one mass, that is neutron. In this way neutron have been discovered. So basically electron was discovered by J.J. Thomson, proton was given by Goldstein, and neutron was given by James Chadwick. As for the charges, electron is negatively charged, proton is positively charged, neutron have no charge. As the masses we observed, the masses, so electron have 9.11 into 10 power minus 31 kilogram, and proton have 1.67 into 10 power minus 27 kilogram. Proton have near about same mass of the neutron, but a little bit slightly greater than that. So it is 1.67 into 493 into 10 power minus 27. So these are regarding the discovery of electron, proton and neutron. Now we will study about Thomson model. So what is the Thomson model? Thomson model. So Thomson model, it was given by J.J. Thomson only. So Thomson model of atom. So it is also known as resin pudding model. Resin pudding model, or it is also known as a watermelon model. Watermelon model. Now, so he have J. Thomson have told it is that this is atom. Wait a second. This is atom. Now this is negatively charged particles over here. When you cut the watermelon, inside there is a seeds. There's the black seeds, that is known as the positive. There is the black seeds, that is known as electrons, and there is the red pulp, that is known as positive sphere. So the electron are submerged in the positive sphere of the pulp. So this model is compared to the watermelon. Seeds are embedded, or resin pudding model, where the resins are embedded in a cake. So this is known as Thomson's model of atom. But there were some limitations about the J.J. Thomson model. Later on, it couldn't give the satisfactory explanation of a scattering of experiment. That's why Rutherford have rejected it in 1911. So now we will just discuss about the Rutherford atomic model. So what were the limitation? Limitation is what? Limitation is simply it was rejected. Thomson model couldn't explain properly the scattering experiment. So could not explain properly about a scattering experiment. So Rutherford have rejected this model. Now we have to study the Rutherford's atomic model. Basically, this is the discovery of nucleus. Rutherford model. This is the Rutherford model. Rutherford's model of atom, and here of atom, and we can also say discovery of atom. Discovery of atom. So now, wait a second. Now, Rutherford in 1911, he have done this experiment. He was very eager to find out the nucleus of an atom. So he did some experiment. So like here I just like to explain something. So he have taken the alpha ray, and he bombarded over the gold foil. This is the gold foil, thin gold foil. So some result have been observed. I just like to explain in my own way. Have a look here. So Rutherford atomic model. Rutherford atomic model. So for any experiment, what do you do? So first you make an aim. So his aim was to find out nucleus. To find out nucleus. Okay. Then after aiming the aim, what do? You need raw material. So what the raw material he have taken? So he have taken the raw material, alpha ray. Alpha ray is nothing, is the helium ion. And the gold foil. So he have taken the gold foil and the alpha ray, and the gold foil was very thin, near about 100 nanometer thick. The thickness was very thin, so it was 100 nanometer thick. Now, what do you do? The third thing, you perform the experiment. So you have also performed the experiment. You have taken gold foil and he bombarded alpha ray. Now, so as he bombarded alpha ray, so most of the alpha ray passes through the atom, just like this, without any disturbance. A few alpha ray passes with some angle, and 1 out of 20,000 alpha ray reflects back on its own path. So after demonstrating the experiment, what do? You do the observation. Observation. So what you observed over here? So you observed something just like this, that first most of the alpha ray near about 99% passes through the atom, without any disturbance, Second, a few alpha ray deflected with some angle. 1 out of 20,000 alpha ray reflects back on its own path. So these are three major observations observed by Rutherford. First, most of the alpha ray passes through the atom without any disturbance. Second, a few alpha ray deflected with some angle. And third, 1 out of 20,000 alpha ray reflects back on its own path. After doing the observation, what do? You just come on to the conclusion. So, conclusion. So what was your first observation? Your first observation was most of the alpha ray passes through the atom without any disturbance. It means since most of the alpha ray will pass through this without any disturbance, it means most of the space of the atom is empty. So since most of the alpha ray passes through the atom without any disturbance, hence most of the space of the atom is empty. Now, since some of the alpha ray deflected with some angle, so there must be some particle near the nucleus, and the third one is some of the alpha ray reflects back on its own path. So both of the observation reaches near the conclusion that since some of the alpha ray deflected with some angle and the 1 out of 20,000 reflects back on its own path, it means the nucleus, since the rays which are deflected with some angle, that was near the nucleus. and the rays, 1 out of 20,000 rays strikes to the nucleus and reflects back, it means there must be some positive charge in the nucleus. Why? Because helium is positively charged, and as you know, the like charges repel each other. So since deflection as well as 1 out of 20,000 alpha ray reflects back, so we can say nucleus is positively charged. So he found that nucleus is positively charged. In this way, he got the idea that nucleus is positively charged particle. No? And nucleus possesses positive charge, and since most of the part is empty and the only nucleus possesses positive charge, means nucleus will have some mass. Only nucleus will have almost all the mass of the only nucleus will have almost all, or we can say just like this, nucleus have almost all the mass of the atom, because as you know, the mass of the electron is very slight, that's a negligible, you can say. So finally we can say nucleus have almost all the mass of the atom. Now, so this is about the Rutherford atomic model. But the thing is what this this Rutherford atomic model have also some drawback. So we have also to study about the drawback of Rutherford atomic model. So what is the drawback of the Rutherford atomic model? Let's study. So drawback of Rutherford atomic model. So what we did he have taken the aim, then raw material, then observation, then conclusion, and finally it's a drawback. We are discussing about the drawback of Rutherford. So what the drawback of Rutherford have? So this is the first drawback. It is the instability of the atom. So what is the meaning of the instability or instability of atom? So have a look here. Simply we can understand this concept just like this. As this is the nucleus, and this is the extra nuclear part. We can say this cell, basically cell. This is the extra nuclear part, which you say the cell, in which the electron revolves around the nucleus. Electron revolve around the nucleus. Okay, now suppose if anything is in motion, suppose I just say you to run, so you will run, and finally get tired and you will fall down. In the similar way, electron will also revolve around the nucleus and revolve, and finally it will get collide to the nucleus sometime. If the collision will happen, so do you think there will be any existence of atom? No. Then somewhere this theory is not perfect about the stability of the atom. So later on we'll also get the idea that who have overcome on this drawback. So first drawback of Rutherford, he couldn't explain the stability of atom. Could not explain the stability of an atom. There's some more drawback. Drawback is what? So he couldn't explain about the line spectrum. Could not explain. We'll just discuss about the line spectrum or something. We could not. He could not explain about line spectrum, and he couldn't explain about the electronic distribution around the nucleus. Now, unable to, or could not explain about, could not explain about the electrons or electronic distribution, about the electronic distribution about the electronic distribution around the nucleus. So this is Rutherford's atomic model. So next we will discuss about Bohr's atomic model or the Bohr's postulate. So what is the Bohr's atomic model? Bohr's atomic model. Just to overcome on the drawback of Rutherford, Bohr's have given his atomic model, and it is known as Bohr's atomic model. He told that it's okay that electron will revolve around the nucleus. Electron will revolve around the nucleus, but not only in a circular path, in a fixed circular path. He used the term fixed circular path. So what was his postulate? His first postulate was the electrons revolve around the nucleus in a fixed circular path known as orbit or a stationary orbit. Have a look here. As the electron will revolve in a fixed circular path, so it will neither fall to the nucleus nor it will go away from the nucleus. So it will move at its fixed path. So there is no possibility of collision of electron and nucleus. So this was the first concept or first postulate, you can say. And second one, he told that only those electrons are allowed or permitted to revolve around the nucleus whose angular momentum will be equal to the which angular momentum will equal to what? Angular momentum is what? This is circular path. Then it will have angular velocity. So mass into angular velocity is the angular momentum. So angular momentum is MBR. So whose angular momentum will be equal to the integral multiple of the h upon 2 pi. So I told you this is the angular momentum. So if electron will move in a circular path, so it will have angular velocity and it will have mass. So its angular momentum is MBR, and integral multiple is of h. It will be angular momentum will be integral multiple of h upon 2 pi. So is the MBR will be equal to n h upon 2 pi. So this is the integral multiple h upon 2 pi. So only those electrons are allowed to revolve around the nucleus whose angular momentum will be equal to integral multiple of h upon 2 pi. Now, what is the so now third one, there is third concept. If the electron jump from, suppose, wait a second. If the electron will jump from higher orbit to lower, then energy will energy will released. And when electron will jump from lower orbit to higher orbit, then energy will absorbed. So he have given the term when electrons are jumped from lower energy level to higher energy level, energy is absorbed and vice versa. So what is the meaning of vice versa? So if the electron will jump from higher to lower energy level orbital, the energy will be released. So this thing you should keep in mind. And this is equal to, here we use the term delta E is equal to E2 minus E1. This is the change in energy. E2 minus E1. Now the thing is what the he have taken. E is the energy. E is the energy part, and energy is minus 2 pi square m z square E4 upon n square h square. As you know, pi is equal to 3.14. M is the mass of electron, and the mass of electron is equal to 9.11 into 10 power minus 31 kilogram. And the Z is the atomic number. Z is your atomic number. E is charge of electron. N number of orbit, as we have studied in the quantum number, principal quantum number. H is Planck's constant, and its value is 6.626 into 10 power minus 34 joule second, and its value is 1.6 into 10 power minus 19 coulomb for the charge of electron. Now when you put all the values, you will get some more values just like this. When you simplify this, so you will get E will be equal to minus 21.8 into 10 power minus 19 divided by n square. This is in joule per atom. So when you want to convert it into electron volt, then you have to multiply 1 electron volt is what? 1 electron volt is equal to 1.6022 into 10 power minus 19. So when you multiply it with the above number, so you will get the value that will be minus 13.6 upon n square, and this will be equal to electron volt per atom. Now, and if you want to make it in a kilojoule, so E will be equal to 1312 divided by n square kilojoule per mole. So this is the value of energy in different form. So this you should keep in mind. So now have a look here. Some other thing. This was given by Bohr's, and he have also studied about radii, stationary radii. So for the radius, he have used the term a naught n square, where the a naught he used is a 52.9 picometer. So if you want to find out for hydrogen, then this n is equal to 1, so 1 square, that will be 52.9 picometer only. Now if you want to find out the radius of some other, so you have to put some the atomic number of that element. That's the thing. If you want to, he have also give some idea about the velocities. So velocity is what he have find. If you want to find out the velocity of the electron of any atom, though, so it will be equal to V naught into Z upon N. Where the V naught is equal to 2.188 into 10 power 8 centimeter per second. So this is a different thing is given by and finally since it is what the Rutherford told electron revolve in a fixed circular path. So since it revolves in a fixed circular path, so it is a stationary orbit, and it is also quantized. It is fixed means quantized. So he used such type of words over here. So all thing is good, but there, as you know, there is some drawbacks everywhere. So there are some drawback in Rutherford's atomic model. What are the drawback? So drawback of Bohr's atomic model. So Bohr's atomic model. So what the drawback of Bohr's atomic model? So the first was he couldn't explain about the line spectrum of multi-electron atom. So could not explain the line spectra of multi-electron atom. What the meaning of the multi-electron atom? So I just like to explain multi-electron atom. Now if you take the helium, so helium is what? Helium, if the hydrogen have one electron, as you know. So if you put the helium ion, so it will have also one electron. So the beryllium, helium, then beryllium is when you put 3 plus charges, hydrogen, helium, lithium. Lithium is what? 2 plus charges. So since all have one electron in present over there. So he have only explained about the line spectra of only one electron atoms, not the multi-electron atoms. That's why his concept was considered as a drawback. Now, second one. So he could not explain about Siemens effect. Siemens effect. What is the Siemens effect? So first let's understand what the Siemens effect. So splitting of lines in magnetic field. Splitting of lines in magnetic field it is known as Siemens effect. Siemens effect. So when the splitting lines of the electrons come into the magnetic field, suppose here the magnetic field, so some electrons will go this side, some this side, some this side. So this is the splitting of lines in magnetic field. This is known as the Siemens effect. So he couldn't explain anything about this one. So this was the drawback of Bohr's atomic model. Nah. There was one more he couldn't explain. That was the Stark effect. Nah. Could not explain about a Stark effect. A Stark effect. So what is Stark effect? So first let us know about the Stark effect. A Stark effect. So the same thing but in electrical field. Nah? So splitting of lines in electrical field. Splitting of lines in electrical field. So suppose we have the electronic lines and we put plus and minus charge. Some electron move this side, some this side. So this is the splitting of lines in a in electrical field is known as Stark effect, and splitting of lines in a magnetic field is known as Siemens effect. This is the North Pole, we can say. This is the South. So this is known as. So he couldn't explain about these two, Stark and Siemens effect. So he couldn't explain about the shapes of the molecule. So how many drawbacks we have? Three, and the fourth is over here, and the fifth is we are discussing. So could not explain about the molecules. So could not explain about the molecules, and explain about the shape of the molecule. What will be the shape of the molecule? So he couldn't give the direction, so how he can give the shape? So and finally he couldn't explain about the dual nature of matter as well as uncertainty principle. So could not explain about dual nature of matter, which was later on studied by or given by de Broglie. It was given by de Broglie. We will study about this later on. De Broglie. And finally he couldn't explain about uncertainty principle. He could not explain about uncertainty principle, which was later on given by Heisenberg's uncertainty principle. So this was the drawback of the Bohr's atomic model. Later on it have been worked so many times, and new concept have been given as the old concept become wrong. Now have a look here. There's some question can come from this topic as well. So we'll just discuss about the numerical part of the whatever the topic we have covered till now, the later on in the next video. So till then, take care. Goodbye.